In this video, we're going to talk about all things vertex form of quadratic functions. All right, so first off, vertex form is expressed as a times the x minus h squared plus k. And we see here's a graph of a quadratic equation. And the vertex point, in this case, is down here, and it's represented by h comma k. So h comma k is shown in the equation here. Now, what does all this mean? Well, h comma k are the coordinates of the vertex. So the h is the x value of the vertex, and k is the y value of the vertex. Now, vertex form is compared to the parent function x squared. Vertex form allows us to determine the transformations from its parent form using where the vertex ends up. H represents the horizontal translation of the vertex. K is the vertical translation of the vertex. A is the vertical stretch and vertical shrink of the vertex. And if there's a negative A, that would represent a reflection over the x-axis. So let's take a look at a couple examples here. So the first one is y equals 1/2 x minus 4 squared. So the transformations, the 1/2 tells us we have a vertical shrink by a factor of 1/2. The horizontal translation is right 4. Now, this is one of the most one of the most common mistakes to make. X minus 4 in parentheses is actually a positive 4 translation. So whatever the parenthesis is, the translation is opposite. Whatever the translation is, the parentheses would be opposite of what makes sense logically to us. The vertex in this case is 4 comma 0. Since there's no value out here for k, it's represented by a 0. So there's our vertex. The domain will be all real numbers. The range will be greater than or equal to 0, which is the y value of the vertex, like we've seen in graphing standard form. Because a is positive, we have a minimum value of y equals 0. And the axis of symmetry is x equals 4 because that is the x-axis, the x coordinate of the vertex. All right, the second example here, we have 3 times x plus 1 squared minus 4. So we're going to stretch this by a factor of 3, so that 3 is a vertical stretch. The plus 1 tells us that it's going to go left 1. Remember, plus 1 is going to be opposite when we translate it. The minus 4 tells us to go down 4, and that tells us our vertex is negative 1, negative 4. Domain will be all real numbers. Our range will be y is greater than or equal to negative 4. That came from the y value of the vertex. The minimum value is equal to the y value of the vertex. The axis of symmetry is the x value of the vertex. All right, so in vertex form, we are not given the y-intercept. In standard form, we're given the y-intercept, but not the vertex. So each form has its pros and cons, but that doesn't mean that we can't find the y-intercept. So in general, the y-intercept occurs when x equals 0. So whatever our function is, we're going to substitute 0 for x and solve for y. So our one example we did prior, we're going to substitute in 0. So wherever I see an x, I'm going to give it a 0. And now we use PEMDAS. So we do our parentheses first, which gives us 1 squared, which is 1. Okay, and there's our 1 times 3 minus 4 gives us negative 1. So negative 1 is going to be our y-intercept. Now, what happens if we want to convert to standard form? Sometimes that is something we need to do. So what we're going to do first is look at this parenthesis. Now, the most common mistake students make is they distribute the power to x squared and the 1, and they would write x squared plus 1. But that is not correct. What this is telling us is that there are 2 x plus 1s. So what we're going to do is use our FOIL or our shortcuts from prior lessons. If you remember your squares of your difference of squares shortcuts we did in a few lessons back. Okay, so we have 2 x plus 1s. So now we're going to FOIL. So first times first gives us x squared. Inside times inside gives us 1x. Outside times outside gives us 1x. So those x's combine to give us 2x. And then last times last is 1, which gives us 1. Now what we're going to do is distribute the 3 into the parentheses. So we call this distributing the a value. The -4 just kind of goes along for the ride. We don't touch the -4 until this very last step. Now we want to combine like terms with the constant terms, which I'm calling the c and the k values. The c technically of this, quote unquote, and the k value from our vertex form. And we're going to end up with a -1. Okay, so we have 3x squared plus 6x minus 1. All right, now how do we create an equation if we're just given a vertex and a point? This has a lot of practical application in order to use this. So what we do is an example, there's a vertex of -4, -2, and it goes through this point. What we need to understand is what all the letters mean in vertex form. So the y value is actually the y coordinate of a point. A is what we're going to end up solving for. X is the x coordinate of a point. H represents the vertex x value, and K represents the vertex y value. So we're going to substitute these 4 points in, and we're going to solve for A. So we have 7 equals A times the parentheses, -7 plus 4 squared minus 2. Again, the y comes from the y value of the point. The x is the x value of the point, and then we have our h and k values. Now we're going to do PEMDAS. So we do our parentheses first, which gives us -3. We're going to square it, which gives us a 9. So this step here, our parentheses and exponent, give us 9a. Now we can easily solve for a by adding 2 to both sides, divided by 9, and we get an a value of 1. So the equation in vertex form is y equals 1, x plus 4 squared minus 2.